Welcome to our official YouTube channel of Hasmukh Goswami College of Engineering, and I am Professor Bhumika Leua from Electronics and Communication Department. And today my topic is even or symmetrical or odd and anti-symmetrical signal. Now this topic is very useful for the university examination as well as in the GATE examination, also in some another competitive examination. So first we will understand what is the meaning of symmetrical or anti-symmetrical. Now the simple meaning of the symmetrical is the similarity, okay, and anti-symmetrical means it's a not similarity property. So see, in our human body there is a left hand side is same as the right hand side, and same way in our nature. Suppose you see the any bird, any plant or any leaf or any flower, so it's same left hand side, whatever the left hand side, it's the same as the right hand side. So it's called as a symmetrical, means it's a symmetrical property. So it looks the things very beautiful. So same way this type of the concept is also used in a signals. So our signals is also symmetrical about the y-axis or the x-axis. Now how these beautiful things are used in a signal? So as we know, our signals are used in a system, okay, and in the system there are number of processing methods or processing operations are used so to operate the signal. So there are different type of the computation methods are used, and it will takes more time to compute it. So if we know our signal is even signal or odd signal, so it will take the less time to computation or simplify. So that's why we learn this type of the signal, that means even signal and the odd signal, in our syllabus, okay. So now to understand the even signal or the odd signal, first of all we have to know about the time reversal property of the signal. So first, suppose I am taking one example of the x of t, that is looking like this, suppose in this way, okay. So how the x of minus t is represented by? So now x of minus t is nothing but the time reversal signal. It's represented by x of minus t, okay. Now this x of t signal, to draw the x of minus t, left hand side of the signal is folded to the right hand side and the right hand side of the signal is folded to the left hand side. So here there is nothing here, so we are drawing 0 here, and this is the right portion that is folded to the left hand side. So this is nothing but the x of minus t signal, means it's a folded signal. This signal is folded to the left or right, that is called the time reversal property. But these time reversal properties are very easy in graphical method. But suppose the equations are given, x of t is equal to t square. So to represent the time reversal signal x of minus t, we are just putting as a t equal to minus t in our original equation. So here t instead of t, minus t square is equal to nothing but the t square. So it's a time reversal property of the signal. Now start the even signal. So the basic definition of the even signal is it's remain identical, that means similar, under the folding operation. This folding operation is nothing but the time reversal operation, okay. So it's remain identical under the folding operation, or we can say it's called as a mirror image, or it's a just type of a reflection, and it's a reversal of the time. So these are the just basic definition of the even signal. So here there is a one graph is shown here. Here suppose x of t, so same x of t, whatever the value of x of t, that is as a same as the x of minus t. So here this x of t, and if I am folded this signal x of minus t and it looks like the same, then it is called as a even signal. So same way in this example, here this one is the x of t. So suppose I am folding this image, that means it's look like this, okay. So it's a x of minus t, and whenever this x of t and this x of minus t are same, then this type of the signal is called as a even signal. So mathematically x of t is equal to x of minus t for all the value of the t, then this signal is known as a even signal. So some of the example of the even signal are cos signal, then sinc function and t square. these all are the example of the even signal. As we know, the cosine function is the even signal. Let's take the cos omega t as our example. So x of t is the cos omega t. So now this is the graph of the cosine function. Okay. Now how to represent the cosine is the even signal. So first of all, this is the x of t. Now what is the basic definition of the even signal? X of t is equal to x of minus t. Means if I am folding my original signal to the left hand side or in the right hand side and the same figure we are getting, then it is called as a even signal. So see, this is the x of t, that is cos omega t. Now whatever the left hand side, whatever the right hand side portion that is folded to the left hand side and this left hand side portion is folded to the right hand side, then suppose I am folding this portion to this portion, so it's become like this. Okay, this portion is reflected in this way, and same way this portion is reflected in this way. Okay, so this is the time reversal. Okay, that is x of minus t, that means it's a cos omega t minus t. Okay, but after performing this operation, both the figures are looking same, so it's called as a even signal, because this is the x of t and this is the x of minus t, but after this operation these two figures are same, that means it's a even signal. Now next is the odd signal. So the basic definition of the odd signal is does not remain identical under the folding operation. So mathematically we can say that x of t not equal to x of minus t for all the value of t, but it is x of t equal to minus x of minus t. If this condition is satisfied, then it is called as a odd signal. So there are number of example of the odd signal. So the most popular example is the sinusoidal signal, okay, then t cube and the signum function. Okay, so these are the example of the odd signal. Now let's take one of the example of this odd signal, that is sin omega t. So x of t is equal to sin omega t, and this is the graph of the sinusoidal signal. So suppose, what is the condition? If I am folding the sinusoidal signal left hand side to the right hand side and the right hand side to the left hand side. So this portion, if I am folding to this side, so what happened? This portion is folded to this side, so it's look like this, and same way this portion is folded to this side, so it's become look like this. Okay, now see here, this is the folding, that means it's a time reversal property, x of minus t. Now see here, this x of t and x of minus t both are not equal. Okay, that means it is not equal to x of minus t. So this condition, but it satisfied this condition. If I am reversal the amplitude, this one is nothing but the reversal of the amplitude. If I am reversing the amplitude, then the same signal we are getting, means negative amplitude multiplied by the minus 1, it's become the positive. Suppose these negative cycles are multiplied by the minus 1, so it's become in this way. Okay, and this positive cycle is become negative cycle, this positive is becomes negative, negative is positive, and this negative positive is negative. Now see this blue line, now this is my signal line, and this signal and this signal, okay, this signal and this signal both are same, but what is the condition here? X of t is equal to minus x of minus t. When this condition is satisfied, then our signal is known as the odd signal. So here the sinusoidal signal is not an even signal. Okay, it's a odd signal. Say take one more example of the odd signal, that is the x of t is equal to t cube. Now how to verify this signal is even or odd? We know that it's a odd signal, but how can we verify? So first of all, we are putting a t is equal to minus t. So x of minus t is equal to minus t of cube. So it's become minus t cube. So if I am putting t cube is equal to x of t, so it's a minus of x of t. Now here the condition is x of minus t is equal to minus of x of t. So can we write down this way, x of t is equal to nothing but this minus is here, so it's x of minus t. So this is the condition of odd signal, x of t is equal to minus of x of minus t. So same condition here we are getting, so it's called as a odd signal. So in this way we can verify our signal is even or odd signal. More important thing in the odd signal, so this one is the odd signal of sin omega t. Okay, so whatever the positive cycle, same is the negative cycle. So whenever we are finding any mean value or average value for the odd signal, so that is always zero value. So the average value or mean value for the odd signal is always zero. So that is the one more important thing for the odd signal. Now let's take one more example of the signal, that is x of t is equal to cos t plus sin t plus sin t into cos t. Now the question is that this signal is even or odd signal. Now as we know, the individual function is even and odd. This cosine signal is even function and this sinusoidal function is odd function. But what about the sin t into cos t? This individual function is odd and this individual function is even, but the multiplication or the product of the two signals, that means it is a composite signal. We don't know about it's even or odd. And if you put t minus t, we replace this t, so cos of minus t plus sin of minus t plus sin of minus t into cos minus t. So this cos of minus t is nothing but it's a even function, so it's a cos t. Again sin of minus t is the odd function, so it's a minus sin of t. Sin of minus t, that is nothing but the minus sin t, and the cos of minus t is the cos t. So again the question is again same. This is the even component, this one is the odd component, but we don't know about this product. So how to solve this type of the example? So this is the general signal. This is the general type of the signal. So whenever the general type of the signal is given, that means it's not a completely even and odd signal, but it is the combination of the even and odd signal. So any general signal can be represented by the its addition of the even component plus odd component. So this is the another definition of the signal. So signal can be represented by any general signal can be represented by its addition of the even component and odd component. Now let's take time reversal of this general signal. Okay, time reversal of this general signal. So we are finding x of minus t. So put minus t instead of this t. So x of minus t is nothing but the x of e minus t plus x of odd component minus t. Okay. Now as we know, for the even component the condition is x of t is equal to x of minus t. This is the condition for the even, and for the odd component x of t is equal to minus of minus x minus t. This is for the odd component. Okay. So put this value in this equation. So can we write down this way, x of et plus minus x of ot. Okay. So this is the another definition. Okay. Now take the addition of these two equations. This equation number 1 and equation number 3. So the x of t, left hand side addition, x of t plus x of minus t is equal to x of e t plus x of e t plus x of t minus x of minus t. So this is cancel out. Okay, so it's nothing but the 2x of e t. Okay, so it's an even component. So from this we can say that for the individual even component can be find out by x of t plus time reversal of the signal divided by 2. So this is the individual even component. X of t is equal to x of t plus x of minus t by 2. Same way we are getting the odd component by subtracting this equation to this equation. So x of t, so same way x of t minus x of minus t is nothing but the x of et minus x of ot, and this one is minus x of t plus x of ot. So here even component is cancel out. So we are getting 2x of ot. So from this we can say that the odd component of the signal is nothing but it's a subtraction of two signal. One is the original and another is the time reversal signal divided by 2. So this is the another important formula for finding the even component and odd component for the any general signal. So for solving this type of the signal, first we will see the different type of the property of the signal. The first property of the signal, that is DC signal, any DC signal is the even signal. So any DC signal is an even signal. Okay, so let's take one example for the DC signal. So x of t, that is the 10 for all the value of the t. As we know, the DC signal is nothing but it's a constant value. So if I am plotting the any DC signal, that is 10 volt, okay. So see here, this x of t is 10 for any value of the time. So for the 0 it's a 10, for the 1 it's a 10, for the 5 it's also 10. Same way for the time reversal signal. So for minus 5 it's also 10, minus 10, 10 it's a 10. So from this figure we can say that it's a even signal, okay, because the whatever the value at the positive side we are getting, it's a same at the time reversal side, okay. So it's called as a even signal, okay. And another way we can prove this DC signal is even signal by finding the component. So as we know, the x of et is equal to x of t plus x of minus t by 2. As we know, x of t for the positive value is always 10 and for the negative side it's also 10. So 10 plus 10 by 2, that means it's again 10, means we are getting the original value. So here we are getting a even component, okay. But suppose I am finding the odd component, x of ot. So that is x of t minus x of minus t by 2. If I am putting the value of this signal from this, so x of t is equal to 10, okay, and x of minus t, that means at the left hand side, that is also 10. So it's a minus 10 by 2. So we are getting 0, means there is no any odd component in the DC signal, but we are getting the even component for the DC signal. So that's why we called as a DC signal is the even signal, okay. So this is the first property and very important property for solving the different type of the example, any general example, okay. So we remember this, the DC signal is an even signal. Second property, if your signal is addition of the DC signal plus any even signal, okay. So the combination of these two type of the signal, so the answer is it's become even signal. How? So let's take one example, x of t. So it's a combination of the DC signal plus even signal. So let's take 10 is the DC signal plus any even signal. So right now I am taking t square, okay. So this is my general signal. Now this combination is always become even. So first we will prove that, and then after we will remember that any DC signal or any even signal plus even signal becomes even signal. So for finding the even, or for finding this signal even or odd, either we are finding the even component or odd component by putting the t is equal to minus t, or same way if equation is given then we are finding x of minus t by replacing the t with minus t. So x of minus t is nothing but the 10 plus instead of this t minus t square. So what is the answer? It's again t square. So this equation is nothing but is our original signal. So we can say that x of t is equal to minus x of t. See here, this x of t and x of minus t are same, so it's a even signal. So from this we can say that any DC signal, or as we know DC signal is even signal, so the addition of the even signal plus even signal are always become as a even signal. So that is the second property of any general signal. Okay. Now the third property is it's a addition of the DC signal, that means it's a even signal plus odd signal, it becomes neither even or neither odd. Okay, so it's a neither even or nor odd. Okay, so let's take one more example. DC signal, that means it's a 10, and the odd function, that means it's plus t cube. So it's a combination of the DC signal plus odd signal. Okay, so first of all we are finding the x of minus t by changing the t with minus t. Okay, so it's become 10 minus t cube. Now compare this equation and this equation. So it's a 10 plus t cube and it's a 10 minus t cube. So it's not equal to x of t. Okay, so that means x of minus t is not equal to xt. That means it's not a even signal. It's not a even signal. Now what about the odd signal? So as we know, for the odd signal this condition must be satisfied, right? X of t is equal to minus of x of minus t. So here x of t we already find out. If I am checking this minus xt we are getting here. So if I am putting minus sign over here, it's a minus 10 plus t cube. Okay, but again compare this equation with our x of t, that is the 10 plus t cube. So again this equation and this equation is not equal. Okay, so that means it's not a odd signal. Okay, so this type of the signal, whenever the combination of the DC signal and plus odd signal, so the answer is it's a neither even or nor odd. Okay, so remember this property again. The combination of the DC signal means even plus odd signal, it's always neither even nor odd. Okay, now let's take the fourth property. So the fourth property is the product of even signal, two even signal are always even signal. So let's take one more example. So t square is the even signal and t raised to 4 is also even signal. So it's a even signal, individual even signal and even signal. So the product of these two even signal is always become a even signal. By checking this signal by putting the t with minus t, so minus t square and minus t raised to 4. So it's always become t square into t raised to 4. Okay, so it's our original signal. So x of t and the x of minus t is equal, that means it's a even signal. Okay, so this is the fourth property. Whenever your signal is the combination or it's a product of the two even signal, even into even, that means its product is always even signal. Same way the fifth property is when the first signal is even and the second signal is odd, then the product of these two signal is always become odd signal. So let's take one more example. T square is the even signal and t cube is the odd signal. Okay, now putting the t with instead of minus t. Okay, so it's a minus t square into minus t cube. So it's become t square into minus t cube, okay, because minus t cube, that becomes a minus t cube, okay. So it's become t square into t cube. So it's become minus x of t. So x of minus t is equal to x of minus x of t. That is the odd condition, okay. So that's why the product of even into odd is always odd signal, okay. Now the sixth property, whenever the two signal are odd signal, okay, so odd into odd, it's become even signal, okay. So let's take x of t is equal to t cube into t cube, okay. Now finding the x of minus t, so it's become minus t cube into minus t cube. So it's become t cube plus into t cube, because minus minus becomes plus. So t cube into t cube. So it's our original signal. So it's a x of t. So again x of minus t is equal to x of t. So it's become even signal. So we remember this thing, odd into odd is always becomes even signal. So this is the sixth property of the signals, even and odd signal. Now let's take one more property, that is the seventh, okay. So the seventh property is when the derivation of the even signal is always becomes odd signal, okay. So let's take one more example. Suppose my signal x of t, that is the even signal, and it is t square. So finding the derivation of this even signal, so as we know the derivation of the t square is nothing but the n into t raised to n minus 1. So it's a 2t, okay. Now this is the odd function, okay, because this t is odd function. So my answer is it's a odd signal. So this is the very most important property of the signal. Whenever we are finding the derivation of the even component, even signal, then its answer is odd signal. Same way, eighth property, derivation of odd component is the even signal, okay. So same way we can check x of t is t cube. So the d by d3 dt of t cube is 3t square. So the t square is the even signal. So the derivation of the odd signal is always even signal, okay. Ninth property, integration of even signal is always odd signal, okay. So let's take one more example. X of t is equal to t square. So the integration of the t square is nothing but the t cube by 3, okay. So this one is the odd function. Same way, similarly we can say that integration of odd signal is even signal. So this is the 10th property of the even and odd signal, and the 11th property of the signal is 1 upon even. If 1 upon even signal is given, then it is always even signal, okay. Now how? It's become 1 upon e is equal to even. So let's take one more example, 1 upon t square. So it's become t raised to minus 2, and if I am putting t with minus t, then it always become t raised to minus t, okay. So 1 upon even signal is always become even signal. Same way 1 upon odd function is always become the odd signal. So now using this property we are solving this type of the example. So as we know, this individual cos t is the even function, okay. Sin t is the odd function, right. Now this is the sin t into cos t. Now this individual sin t is the odd function and this cos t is the even component, right? Even function. So it's a product of odd into even. Now as already discussed, whenever any signal is the product of any odd and even signal, then its output or its a combination is always odd function. So right now this total function is become as a odd function. Okay, so from this property we can easily identify which type of the function is even and odd. So directly we can write down the even component and odd component by using this property. So the even component is only cos t, but odd component is this sin t plus sin t into cos t. So by using this type of the property we can easily solve this type of the general signal, and this method is very useful for any competitive examination. Okay, now let's take one more example of this type of the property. So x of t is equal to t square sin t minus t cube sin square t plus t cube cos t minus cos cube t upon t square. Okay, now finding even and odd component of this general signal. So right now we are applying these properties. Okay, so the t square is even signal. Okay, and this sin t is the odd signal. Okay, so this is the product of even and odd signal. Now we know the property, whenever your first signal is even and the second one is the odd signal, so the combination of even and odd is always odd component. Okay, so this one is the odd component. Same way we are checking the individual part. Okay, so the minus t cube upon sin square t, so this t cube is odd signal, right, and this sin square t, so individual sign we know it's a sin t into sin t. Okay, so it's become odd upon this sin t is odd and this sin t is also odd. Okay, so this odd into odd, it's become, using property odd into odd, it's a even. Okay, now odd upon even, so we can say that 1 upon even into odd. Okay, so this 1 upon even is nothing but is always even signal by using the property, and the even into odd, so the property of the even into odd is always become odd property, right. So again this component is the odd component. Okay, so here this components become, this total component become is the odd signal. Same way t cube into cos t, so as we know t cube is odd signal. Okay, and this cos t is the even signal, so again the product of odd and even is always odd signal. So again this component is the odd component. Now let's take cos cube upon t square, so the cos cube upon t square, so this cos cube is nothing but the cos t into cos t into cos t, and this one is the even signal. So this one is even signal, so even signal into even signal into even signal upon even signal, so again it's a 1 upon even, so it's again become even signal. So even signal into even signal into even signal into even signal, 4 times even signal. So this combination of 2 even signal is even signal, and this combination of 2 even signal is even signal. So again it's even into even, so it's become a even signal. So only this component is even signal. So by only applying the properties we can identify from our the signal which are the odd components and which are the even component. So whenever the writing for the even component and odd component, so here the answer is x of t is only cos cube by t, cos cube 3 by t square. This one is the even component of our signal, and the odd component are t square sin t minus t cube sin square t plus t cube cos t. And the same answer we are getting by using the mathematical formula by putting the minus t instead of t and finding the x of et by using x of t plus x of minus t by 2, or x of ot is equal to x of t minus x of minus t by 2, but it becomes very difficult. Okay, so that's why we are using this type of the shortcut method to solving the problem. Thank you for watching my video. If you like this video, share it and subscribe it.